go 8, 2, we'll put it in. We're going to hypothesis test. For the difference in population means for, what was it yesterday?
Small.
Yesterday was large, today is small. Sample. So we're still doing means. Small sample. So because it's a small sample, first thing has to be given. Each population must be given as normal. If they're not, you can't do it. So each population must be given as normal. Large samples, you don't have to have that because of the central limit theorem. Excuse me. Here we are doing independent samples, so there's no overlap. Tomorrow we're going to do dependent samples. And your critical values here, what do you think they are? T's. That's an LE. Critical values here are T values. Large samples are always Z's. So when we do the shaded region, you're going to be using your T-table. Now turning your sample difference into a T-score. There are two formulas. And here they are.
I wonder what college stats would be like without those note sheets.
What note sheets?
The Z-scores and T.
Oh, well, yeah, you would be able to do that. So you take your difference in the sample mean, subtract the difference in the population mean, coming from the whole, divide by, well, it's just like yesterday. S1 squared over N1, S2 squared over N2. Okay. So you use this formula if you are given that the population variances are not equal. So you will know this information about population variances. They have to tell you this. When they're not equal, that's considered not pooled.
I don't know. I'm really. You said not cool.
Not pooled. And remember, when we read the T-table, our vertical column is degrees of freedom. And it's always been, what has been our degrees of freedom? N minus 1. Well, we've got two sample sizes going on here. So, degrees of freedom is either going to be N1 minus 1 or N2 minus 1, whichever one is the smallest. So whichever one of those comes out the smallest, that's the degrees of freedom you use. Yep.
Smallest after the subtraction.
Yes, whichever one comes out smallest after the subtraction, that will be the degrees of freedom you use on your T-table. Okay, so if we've got something called not pooled, that means we must have something called pooled, which is going to change the whole formula.
That means the variance.
The variances are going to be given as equal, the population variances. So, or, you're going to love this formula. the numerator doesn't change. We're going to have x bar 1 minus x bar 2,
Yeah, it was dark.
mean 1 minus mean 2 from the whole. Here your denominator gets a whole lot uglier.
Oh boy.
And 1 minus 1 times s1 squared plus and 2 minus 1 times s2 squared, all divided by n1 plus n2 minus 2. And if that's not enough, you're going to multiply that by the square root of
Why does this exist?
1 over n1
When are we ever gonna use
plus 1 over n2.
Wait, so
Okay.
we're dividing the square root by a square root?
No, we're dividing by 2 square roots multiplied.
What?
That's a square root here.
Just do it one thing.
These are being multiplied.
Alright.
So the denominator is the square root of all this times by the square root of all this.
So
What?
let's just make sure this doesn't happen.
What does not fold do?
We'll change
I have
the
no
vari-
idea.
We will change the variance.
how do
Other
you know
than-
it's not fold?
They have to tell you. Well, they won't say pool or not pool. They'll tell you this. They'll tell you these are not equal. You've got to know that that means not
So
pooled.
that means not fold, and then this is for if they are fooled?
Yep.
Oh my goodness.
So
These
in
are
other words, we're
pooled.
gonna change the variance every single time.
Those are considered pooled. And then your degrees of freedom here, it's different than it is up there. You're going to add the two sample sizes together and subtract 2.
Can we just burn this?
Nope. That's probably your ugliest formula we're going to have all year.
That's probably the ugliest formula I've ever seen.
I think I finished the top one.
That's because you were carrying on a whole conversation while I was talking through that.
That's true. I mean, that's interesting. Yeah.
There's nothing to come back to.
Okay. I see 2 examples in my notes. I wonder what I'm going to have for you.
Very.
One pooled, one not pooled, I see coming your way. See how you deal with them.
Perhaps. Can we do the fold one first? Yeah.
You want the pooled one first.
Yeah.
Where is that?
Oh, well, I don't know if it's
Oh,
really
okay,
start off
got
hard
it.
and then we'll go down.
I got it. Are we ready? Yeah. Okay, here we go. I do have the pooled one first. A manufacturer claims
Ready.
that
No.
the mean of his product, I don't even remember what this was, is less than his competitors.
Right?
Must be mean price. There, we'll put price in there. The mean price of his product is less than his competitors. And here's what we know. Both populations are normal. And the population variances are equal. And we're going to test this at 0.10 if possible. Okay. So here's the manufacturer. His mean price is $73. Standard deviation 2.4. Sample size was 12. The competitor, $74. 3.2 on the standard deviation. 15. So first of all, on a test, realize these are small samples. Dealing with means, we have to know both populations are normal to continue. And I did give you that. So we are okay to move on with t-scores.
Wait, question.
Yeah. With what?
You go.
Okay, so are you gonna, well, know that it's technically, even if we didn't know that it was a small sample, so 5 CO squared 1 is not equal to or equal to the.
That would be a hint that it would be this section in t-scores, yes.
What if the manufacturer was 12 and the competition was 30? That's what I was confused.
I'm gonna say, because he's one small, you gotta go with a small, this,
And that'll work?
yes.
Holy ever have, yes.
I don't think so, but if there's one small, you can't make it a big, but we could make big down to small.
Like, all toes off, all thumb, fingers, middle fingers and thumb.
Okay, we'll go with that. All right, so we got to write the claim as a difference. So our claim, so I like to start with the way it's written and then rewrite it as a subtraction. Some people can go right to the subtraction, however you want to do it. The claim is that the mean from the manufacturer, that's my mean M, he says his mean is less than the mean of his competitor. Now write that as a subtraction because we're testing the difference, so we'll subtract the mean of the competitor. So you get the mean of the manufacturer minus the mean of the competitor is less than 0, making the claim the hot. The whole difference will be greater than or equal to 0. Okay? Left tail, right tail, two tail. Left tail because the ha is pointing left. .10, and this critical value is a T, not a Z. Okay, and to read the T table, you need your degrees of freedom.
You don't, whatever, smaller.
And this is the pooled one.
No, you don't, never mind.
So we got to look back at your notes that we just did.
Add them up.
So when it's pooled, you add them up and subtract 2. So DF on this one is going to be 12 plus 15 minus 2. So what are we going to have there? 25? So 25 DF, and the amount in the tail is 0.1. One tail.
316. Great.
Okay, 1.316 is going to get you minus a half.
It's a negative one.
It's a negative 1.316. You supply the negative because it's on the left tail.
You just made a triple equal.
I know.
It's really equal.
Alright, it's really equal. Okay, now we've got to do that ugly formula and test your calculator skill. Let's set it up first though. So we need the t-score for the manufacturer mean minus the competitor mean. Because I did the claim as manufacturer minus competitor. So we're going to go 73 minus 74. Minus the 0. Do yourself a favor and do a little bit of simplifying in this square root. Formula says to take n1 minus 1, so that's going to give me 11, multiplied by the 2.4 squared, plus 15 minus 1 will give you a 14, multiplied by the 3.2 squared, over, and again, you already did n1 plus n2 minus 2. What did you get? 25. Just put the 25 down there. It'll save a whole lot of button pushing and mistakes on the calculator. And then we just got to extend our fraction bar because this is going to be multiplied by the square root of 1 over 12 plus 1 over 15.
Wait, what is the one coming from again?
The 1?
Yeah.
1 over n1?
Oh, okay. That'll be fun.
Okay. If it takes you 10 lines, it takes you 10 lines, whatever you need to do.
Can you put like the 11 times 2.4 and leave the square root without,
If you're good.
you know,
Anything can
let's
be
just
done.
try it out loud. See what happens.
It can all be done in one line if you're good. Some of you are not that good, just so you know. You might want to write some stuff down to get there.
Oh shoot, I got it.
Oh, syntax error, that's definitely not right.
Haven't done that yet. Oh, found it.
Found it.
Got it. Negative point,
Wait.
0.4.
No.
No. Woo. Get it.
Do you guys get a negative .897?
Yep.
Yeah.
Oh boy. Oh boy, oh boy, oh boy.
Look, it's 898.
Yeah. And then the next thing I do, the cost came.
I've tried this.
I'm just trying.
We're trying
All in
again.
one line.
Taking the challenge of all one
It's
line.
nice, cause I do have to do like this.
I know,
That
I
was
forgot about
line
the
part.
keys.
You can insert. Inserts
You know, but I
there.
should go all the way back.
Oh, well.
I'm just gonna go with it.
No, go, come back. It's not gonna work.
Watch that. It's not worth it by 12
Wait, what did you guys get?
times 5.
Negative .898.
I got negative.
Ready? Wait, what is it?
Negative .898.
God.
Ah, good.
Okay, wait, I'm gonna try inserting another one.
Negative .898. Anybody wants me to do it on the TV?
I got the same.
Yeah,
thing.
in one line, I want to do
See it
that.
in one line?
I just did it in one line.
Challenge accepted.
It was really hard. I used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
Okay, one line.
15 friends.
Here we go.
Is that one line?
73 minus 74 divided by, I got two things multiplied down there, so I'm going to start with the parentheses.
Oh.
Yeah, I got that.
Okay, square root. I've got a big numerator there, so I'm going to do another parenthesis. 11 times 2.4 squared plus 14 times 3.2 squared. That's
Oh,
my
yeah.
numerator.
Okay.
Divide by
Why am I getting a K?
25, stopping that square root.
Yep.
You can put a multiply or not a multiply, doesn't matter. I'll go multiply. The next square root, 1 divided by 12 plus 1 divided by 15. Stop the square root. Stop the denominator. Oh, it can be done.
I added like,
That's the least amount of parentheses needed.
I added
Nothing-
like
No,
3
you don't need the
parentheses
first
in
one,
front of
you
the
do
first
negative one.
square root.
Oh, well, if you type in 73 minus 74.
technical way to do that?
Huh? The easier way to do it?
Yeah, that.
Okay. Work out the top, -1.
Yeah.
Then I'm gonna work out that bottom square root, but without the square root for now. So,
Oh.
I would quit. I would go with no square root. 11 times 2.4 squared plus 14 times 3.2. Get that answer. Divide it by 25. And then square root that answer. I'd write down 2.08 on my paper. Okay? So that whole square root of the first one is 2.08. You with me so far?
Isn't it 3 point, no, you messed up.
Did I?
3.2 squared.
Oh,
is
shoot.
too far.
Let's see that.
So it's 206.72.
Squared. Okay. Divide by 25,
Oh my god.
and then square root that answer. Now I'm gonna write 2.88 on my paper.
You're better at doing it in one line.
Yeah. So now the next one, I'm gonna go 1 divided by 12 plus 1 divided by 15. Get that answer. Square root that. 0.39. And now I'm gonna go back and find my answer of -1 divided by those two things multiplied. It was 2.88, because I have it written down, times 0.39. And it's not gonna be perfect, because I rounded a lot of stuff, but it'll be close enough. So I did it in little pieces, and then went back through with the easier numbers. So however you need, whatever you need to do to get there, you get some good calculator skills going. Okay? All right, second one.
That took 10 minutes. That took 10 minutes.
And the people watching the video saw nothing, so that's a really slow 10 minutes there. Okay, we're gonna be comparing.
While you're filming,
Yeah.
add me on Snapchat, @JPaulDouglas.
Clean.
Hey, Mr. Wright, do we have to say something like?
Oh yeah, we didn't finish it, for goodness sake. Took all that time. What region are we in? Fail to reject the whole. And it is neat.
We failed to reject the whole after all of that.
Yes.
Right.
Okay. The mean braking distances. Okay, we're comparing two snow tires and braking on, I don't know what was it, snowy pavement, I don't know what kind of pavement they were. But they did a test. They compared two brands of snow tires. There was Winter Fire and Alpen tires. No, those are real. Both of these are real. Okay, the mean braking distance, like I said, I don't remember the conditions. 102 feet. Standard deviation, 10 feet. I think it's Alpen.
That's really bad.
No, I didn't spell it wrong, it's Alpen. Sample size was 10, small sample.
10 sets or 10 tires?
10 trials, probably 10 different sets of tires. 94 feet, 4 feet, tested 12 times.
How fast were they going?
I'd have to look. It said, I don't remember. I want to say like 45. So, populations are normal. Population variances are not equal. And 5%. All right. So we're going to rewrite the claim with our symbol and then write it as a subtraction. And it doesn't matter which one you put first, Winter Fire or Alpen, but what the claim is that they are different, not equal. So the mean of the Winter Fire is not the same as the mean of the Alpen. Yes, we can see they're different, but is that difference significant? Or are they close enough to be in the normal curve where they're not considered different? So now as a subtraction, Winter Fire minus Alpen does not equal 0 as your Ha. Oh. So we've got small samples, not pooled, still T-scores. Two-tailed test because of the not equal. 0.025. We need our DF to look these up. How do we get DF on not pooled data?
Like a normal person.
Whichever one's the smallest.
Smallest. Sample size minus 1, pick the smallest.
So 9.
So 9 would be our DF.
0.05.
2.262.
Are we in agreement with Lucas?
Absolutely.
Oh, 0.
Positive and negative 2.262?
Yeah.
As long as I see that on the test. You do have to show me everything. I can't remember when you get your test back. If you're not writing both of these, you're losing points. If you're not using the right symbols, you're losing points. If I don't see this, you're losing points. Now our plug and chug. So the t-value for the winter fire mean minus the Alpen mean. And our not pool denominator is the same as yesterday's denominator, where we have the 1 square root down here, which is the standard deviation squared over the sample size.
So 10.
Yep, and then 4 squared over 12.
That's good.
And then you'll be done.
Thank you. Yeah, no. No, you just. Just that one.
And anything yet?
I got 2.3. I like my thing.
That was true.
I don't have it this time.
26.7?
That's 26 does not sound correct. You got some bad calculator skills going on. I will come and help you.
I got 2.38.
2.38.
Hold on. I need to think.
I didn't do it wrong.
Yeah.
3 against 1. I don't have the right answer though.
Wait, what is, yeah, I got 2.38.
Nope, 4 against 1. Holly, I'm gonna kind of lean the other way.
Okay.
Holly, you're back.
Whoa.
Okay?
Check.
Reject the hoe.
That's
And
gonna be it.
Claim is true. That is a significant difference. Those Alpen tires do look like they are a better tire for braking on their conditions. Okay.
I put one end of the parentheses, but not the other end.
Causes some issues, doesn't it? Alright, assignment.
can we not have this obnoxious assignment?
Page 385.
Number 1 and number 2.
The beginning's really good. Yeah, it's
I wanna
like
go.
the opening.
I have 11 through 16.
Sure.
What?
Do you know how obnoxious the formulas are?
Don't care.
Sure.
Don't care.
Please.
Work.
I have to do it.
I'm just gonna go with.
Work.